Hi everyone. So I have for you today an INMO 2005 problem, which is basically a functional equation. Basically, you're asked to find all functions satisfying some condition. So let's get to it. So in these kind of problems, the first thing you do is try to plug in everything 0 and see what do you get. Okay, so that's the most basic thing to do. So if you plug in x is 0, y is 0, z is 0, you will see that here's a quick rough work. So you see that f of 0 is equal to 0, right? So that's the basic thing you get. F of 0 is 0. That's the first observation. Okay, so the first observation is f of 0 is equal to 0. Okay, so now we can try to do other things. For example, we could try to put certain variable 0 but keep the certain other variables, non-zero. So for example, we could try to put in x is equal to 0 and see what do we get. So you put in x equal to 0. Let's do our rough work here again and we'll summarize it there. So you'll see x is 0, so y f of z is equal to z f of y. Something's going on here. Y f of z is z f of y. So let's try to use it to our advantage. If we try to put anything 0, it won't help. You'll get f of 0 is 0 again, because that's how we got it. So let's try to put z is something else. Let's try to put, say, z is 1 or y is 1. So we have two possibilities. Let's see what do we get when you put z is 1 or y is 1. Okay, so if y is 1, you see that I'll get f of z is z times f of 1. Okay, that's one thing. If you put z is equal to 1, you will see that f of y f of 1 is equal to f of 1. Okay, so now let's see what happens here. There are two possibilities. F of 1 could be 0. Okay, now what happens if f of 1 is 0? If f of 1 is 0 here, if f of 1 is 0, then you see that this will simply give you f of 0 is equal to f of y. Okay, but f of 0 we have already shown as 0. So this will give you 0. So in other words, f of y is 0 for all y. So it's the 0 function. Indeed, the 0 function does satisfy. So that's one of the solutions. Okay. So one of the solutions to this problem is f of y equal to 0. Okay, the function f that is identically 0, as it's generally called. We'll write it as f triple 0. That's one solution. Okay. So we found that. And that is if f of 1 is 0. So from now on, let's assume f of 1 is not 0, because if f of 1 is 0, we already found a solution. So we'll assume f of 1 is not 0 from now on. Okay, let's assume f of 1 is not 0. And in that case, what happens? So here, f of 1 is not 0. Right? The function on the right is some g of z is equal to, if you call it f of 1 as some alpha, it's alpha times z. And alpha is non-zero. So the function g of z is alpha times z, where alpha is non-zero, is an invertible function. So you have f compose f is equal to g. And g is invertible, so f is invertible. Okay.
Wait, why is f invertible? Let's discuss that now. If I give you two functions a and b, if I know some properties of b compose a, what can I say about b and a? If b compose a is 1, 1, we can conclude actually a is 1, 1. On the other hand, if b compose a is on 2, we can conclude b is on 2. In our problem, we know that f compose f is g. Further, we know that g is invertible. Okay. Applying 1 and 2 on the top, we can therefore conclude f is 1, 1 and on 2. Therefore, f is invertible.
This we can now use because we can go back to this particular equation. Okay, so let's go back to this equation where earlier we plugged in f of 1 is 0, but now let's come back to it. If f is an invertible function, f is 1, 1. So if f is 1, 1 and f of y f of 1 is equal to f of y, then that would imply y into f of 1 is equal to y for all y. That in particular, if you put y equal to 1, that means f of 1 is equal to 1. So once f of 1 is not 0, we could conclude that f of 1 must be 1. Okay, f of 1 must be 1. So you have two possibilities. F of 1 is equal to 0. Okay, f of 1 is equal to 0, in which case f is identically 0. Or you have f of 0 is equal to 0, f of 1 is not 0, in which case this implies f of 1 is 1. Okay, f of 1 is 1. Now notice something interesting happens. If f of 1 is 1, f of z is z. So if you plug in y and z 0, you see that you'll get f of x square is equal to x f of x. Awesome. Now, the other thing is, if you plug in x is 0, then you'll get, which we wrote earlier, but I'm writing again, y f of z is z f of y. You have these two equations. Now notice that f of x f of x is x f of x. Okay, so if you plug in y and z equal to x, you'll get f of, put y equal to z equal to x. Okay, if you do this, you'll see f of x f of x is x f of x. Okay, and if you now compute what this is actually nothing but f of x square, right? From the first equation, from here, if you call it 1, you have from 1 x f of x is f of x square. Now notice f of x is f of x square, but f is an injective function. It's invertible, so it's, you can apply f on both sides if you want, but it's invertible. So x f of x is equal to x square, okay, for all x. Now if x is 0, then f of 0 is 0, so no problem. But if x is not 0, then f of x, you can cancel x on both sides and get x. So therefore, this will force f of x to equal x. So the only two solutions are f is 0 and f is identical.